All right, let's jump right in. Today, we're going to trace the evolution of distributed ledgers. We're going to go from a single, brilliant idea all the way to a technology that could literally change how entire industries work. So let's get into it.
So, we all know blockchain is the tech that makes crypto possible. But if you're used to working with normal, centralized databases, you have to ask, what was the point? What was the fundamental problem it was actually built to solve? I mean, what was so broken that it needed this whole new way of doing things?
Well, it all boils down to something called the double spending problem. Now, in a traditional system like your bank's ledger, this is a total non-issue, right? The bank is the single source of truth. It takes money from one account, puts it in another, and that's that. You can't spend the same dollar twice. But in a decentralized system, with no one in charge, how do you stop someone from just, copying a digital coin and spending it over and over again? That was the #1 challenge for creating a purely digital cash system.
And this is where Bitcoin's solution was, well, kind of genius. Here's how it works. First, every transaction gets broadcast to everyone on the network. Then, a bunch of those transactions are gathered up, time-stamped, and bundled into a block. And here's the crucial part. This new block is cryptographically chained to the one that came before it. Finally, to lock it all in, adding a new block requires solving an incredibly difficult math puzzle. We call this proof of work. The result is this public, unchangeable record that makes it virtually impossible to spend the same coin twice without everyone knowing.
Okay, so that's the big picture. But let's get into the nitty-gritty. How do those two core pieces, the public key cryptography and the proof of work, actually work together to keep the whole thing secure?
Well, they're like two sides of the same coin, and they work in perfect harmony. Public key cryptography is all about who. It's your digital signature. It's the proof that you, and only you, own the funds you're trying to send. Then you have proof of work. That's all about the what, the integrity of the ledger itself. It's how everyone on the network agrees on what the real history of transactions is. And importantly, it creates this massive economic wall. Trying to attack the network would require a frankly insane amount of computing power, which costs a ton of money. And this proof of work idea is pretty much what it sounds like. It's a system that forces participants, who we call miners, to spend real-world resources, we're talking electricity and raw computing power, to solve that puzzle. The first one to crack it gets to add the next block to the chain. It's this work that makes the whole system trustworthy without needing a central bank or referee. It makes creating blocks hard, and it makes changing them even harder.
So Bitcoin came along, laid the groundwork, and proved that a decentralized digital currency could actually work. But it wasn't the only game in town for long. Which leads you to wonder, were there other folks trying to build on this idea?
Oh, for sure. And one of the most interesting early players was Ripple, because it represented a totally different way of thinking. Instead of building a public cash system for regular people, the creators of Ripple looked at the existing financial world and asked, what if we used this tech to solve a huge problem for big banks? Like how slow and expensive it is to send money across borders?
And this table just lays out the split perfectly. On one hand, you have Bitcoin, public, decentralized, a true peer-to-peer cash system for absolutely anyone. And on the other, you have Ripple, a private, permissioned network where all the players are known and trusted, built for one thing, speedy bank settlements. So right away, you see the technology being pulled in two totally different directions, one toward a permissionless public good, and the other toward a super efficient tool for private businesses.
All right, so that sets the stage for the next massive leap forward. Bitcoin was a revolution, for sure, but it was really just one application, a ledger for tracking who owns what. So if Bitcoin is digital money, what is it that makes people call Ethereum blockchain 2.0?
The game-changing idea was just one word: programmability. What if a blockchain could do more than just track value? What if you could embed actual logic, rules, and entire agreements right into the system itself? It wasn't just about money anymore. It was about programmable money.
And that's the idea behind what we now call a smart contract. It's basically a program that runs exactly as it's written, and nobody can stop it or change it. The example here is perfect. Imagine flight insurance. A smart contract is linked to a trusted flight data feed. If your flight gets delayed, the contract sees it and boom, automatically pays you out. There's no claims process, no paperwork, no third party you have to beg for your money. The agreement just executes itself.
So this is a really important difference to get. Bitcoin is the application. It's a decentralized app for tracking money. But Ethereum is a platform. It's like a decentralized world computer that lets you build and run any kind of application you can think of.
Now, this idea of programmability is incredibly powerful. But, as we kind of saw with the whole Ripple story, public, anything-goes networks aren't always a great fit for the business world. I mean, for a lot of companies, things like privacy and control are everything. So how are big enterprises taking this tech and making it work for them?
And that's exactly why we saw these enterprise-focused platforms pop up, like Hyperledger and Corda. They were designed from the ground up for business realities. You can't just have anyone join your global supply chain network. You need permissioned access. You can't broadcast the sensitive details of a private financial deal to the whole world. You need data privacy. And you probably need something way more efficient than Bitcoin's proof of work. These platforms rethink the whole architecture to fit what the corporate world actually needs.
And this potential really brings our whole journey full circle. This quote says it all. Some people think this tech has the potential to upend centralized database practices across finance and pretty much everything else. I mean, think about it. We started with one very specific problem, how to not copy digital money. And we've ended up with a technology that could fundamentally change how the world does business.
So, where does that leave us? Well, the implications are just huge. If we can use smart contracts to automate legal agreements, and we can use enterprise blockchains to make supply chains more transparent, what's next? What's the next business process we all take for granted that's about to be completely rewritten by code?
That's what we've got for this explainer. If you found this breakdown useful, do me a favor and hit that like and subscribe button for more deep dives. Thanks for watching.